morning, everyone. For those newly joining us, my name is Allison Hazel. I'm the conference manager with Power Plant World Asia, and welcome to the second day of our conference. I'd like to thank the first day speakers for so excellently kicking off our program yesterday and encouraging us to use our brain and think about plant efficiency and productivity. Today we're picking up the discussion with topics on reliability and maintenance, productivity and cost management, and technology and carbon reduction strategies. I'd like to reintroduce Graham, who is our lead consultant from Marina Technologies, based out of Queensland, Australia, and he's our chairman for the event this year. So I'll turn it over to Graham.
Hang on, Mr. Chairman. I was saying yesterday I'm not very good at humour, so very pleased to see that you laughed at my quick quip. Just a few housekeeping matters. Once again, if you could turn your phasers to stun and your phones to silent, please. Who has their phaser here? That was another joke that was a complete failure, so I had one smile. No, it's important, so if you could just switch your phones to vibrator or silent, please. Just a reminder that all the presentations will be available online after the conference. Not straight away, there will be a delay, about a week we think. So if you have any questions about that, if you could contact the registration counter. As we did yesterday, we're encouraging active participation in the presentation. So in order to help us with the timekeeping though, we'll be leaving the questions, each presenter will make opportunity for questions and discussion at the end of their session. So if you have some questions, quickly make a note of them and we'll get to your questions at the end of each presentation. Now, unfortunately, we have some schedule changes just to make you aware of. Hopefully you would have received an updated agenda for today as you walked in. If you haven't, there'll be a Terrapin staff member you can get that schedule from. The changes predominantly relate to, unfortunately, Stuart McWilliams from Seneco is unable to be with us this morning. With not one but two emergency situations. So he sends his apologies and hopefully he may be able to join us later in the day. I'm certainly looking forward to hearing what Stuart has to say, so I do hope he is able to join us. Just a reminder as well, there is a post-conference masterclass on tomorrow. There are still seats available. Excuse me. I'm actually running the masterclass tomorrow, so there'll be an opportunity for me to have some more direct interaction with you all, and I'm looking forward to that. So if you aren't registered for that and you are available to attend, please see Alison after this. You would also, in your conference booklet, if you look in the back of the conference booklet, there's an orange evaluation form. Terrapin, as I've come to know them, are a decidedly customer-focused organisation, so they're very keen to make sure they're meeting your needs, and a very concrete and practical way they can do that is to receive your feedback on the evaluation form. So between now and when we leave the conference, we certainly encourage you to complete that evaluation form and hand it back to one of the Terrapin staff members. Thanks. So lunch today will be located, as it was yesterday, within the exhibition space and in the halls surrounding the exhibition. In the nearest hallway here, there is halal food available for those who need that. I've had a bit of a challenge getting hold of Wi-Fi. Who's had trouble with Wi-Fi? It does actually work out near the glass, I've found and been told. So it won't work inside here or in the exhibition hall, but if you do need Wi-Fi, it's out near the glass windows. It actually does work out there near the escalators. And one final thing, just in in terms of housekeeping. In your individual companies, could I have a show of hands who uses the discipline of having a safety moment? Is that, have you heard the term a safety moment? So basically every meeting that you have in the company, there is an emphasis, even if it's only for 30 seconds, but to remember safety in every interaction that we have. So here is your safety moment today. I just wanted to remind you of the emergency exits, and there is a potential cause for confusion, so I want to get this right. If there is an emergency and you have to evacuate the building, then from this room you turn left, and contrary to what the green signs will say, the green sign, after you turn left, when you're in this hallway, the green sign will say exit right to get you to the escalators. In the event of an emergency, however, you must, having turned left here, you must turn left again and head all the way to the end of the long hallway, and there are exit stairs external to the building. So if we hear, I'm not exactly sure if we hear sirens or if there is an emergency exit, it's left and left again. Now, let's come back to the safety moment. Why am I making a fuss about this? First of all, it's to make a point about the safety moment, and if your company is not doing something like that, something equivalent to the safety moment, could I encourage you to catch up with Dan and he'll give you the inside story on why safety moments are so important. And the other thing, of course, is in practical terms, we want to make sure we're looking after you. So, I mentioned the change in schedule, so we're starting off this morning with Daniel Dexter, the Chief Operating Officer of China Light and Power India. Daniel has quite a distinguished career. He's got, as we heard yesterday, more than 30 years experience in a wide variety of situations, including regulated and unregulated the power industry. I really enjoyed listening to Daniel yesterday and looking forward to hearing him speak again. Today he's speaking on making the right maintenance decisions, refurbish, retrofit or replace. Would you join in welcoming Daniel to the stage?
Thank you. Nice introduction. Put slides up. Good morning. Very lucky to get to speak early in the morning before everybody gets a little bit sleepy. This presentation is listed as a case study, but what it really is an example of a process that we went through in a specific plant. You will find that there's nothing really new or innovative within this logic or this process. The key point is it's just an example. Everybody's plant is different. And you really must evaluate all of the factors that you're facing in your operating regime, your regulatory regime, from the point that you start looking at these decisions that have to be made for the long term. So, just a little background. Just to explain CLP as a company, CLP is a wholly owned subsidiary of CLP Group out of Hong Kong. It's a wholly owned subsidiary. We have just completing a 2x660 supercritical coal plant. We have a 655 megawatt gas combined cycle plant, and we have a lot of wind in various states throughout India. So you can just kind of see geographically where we're scattered within India. The plant that we're going to talk about today, the Pakutan plant, was acquired by PowerGen in 2002. The plant was actually built and fully commissioned by late 1998. This facility consistently maintains an excellent safety record and performance record. But we're particularly proud of our lost time injury record. It's been over 12 years with no lost time injury. And we participate in the NOSA review process, which looks comprehensively at the operations, safety, environmental performance, etc. And for the last 2 years, we've received the NOSCAR award. So we're quite proud of this facility. Every plant in the world, as I said, is different. And so commercially and technically, you have to look at the plant and decide what you will do on a life assessment. So what were the strategic factors we looked at for our Powhatan plant? We looked at the PPA expiration date. Right now we have a very good PPA, but this PPA will expire in 6 years. Then we will have to have the option of renewing a PPA that will be on less favorable terms and conditions, merchant market exposure, maybe a combination of both, third-party sales. We have to look at the regulatory changes that will involve increased efficiency, reduced emissions, reduced water usage. CLP is a very proactive company. We've done a lot of work already to improve our emissions in India without even the regulators coming forward and saying you must do it. But now sometimes we're our own worst enemy. We have regulatory people now stepping up and becoming aware. They're doing baseline studies, and they're giving targets to all of the industries to reduce emissions, reduce water consumption. Because we've already been doing this over the years, it makes it even more challenging for us to reduce even further, where other industries will be able to just begin the process. Overall cost of production, cost of maintenance, the overhead cost, productivity and organization structure optimization, root cause analysis of operating history and prioritization of forced outage incidents, equipment replacement, upgrades, outage minimization, scheduling optimization, technical and economic analysis, all while still considering CLP standards for sustainability. So these are many of the strategic factors that we looked at that were unique to our plant. Then of course there are the technical factors. When we get all of our engineers together in a room, they have a lot of ideas on things they'd like to do. If they had an unlimited capital expenditure budget, they'd completely transform the plant. But sometimes that's not economically viable. So some of the typical things that you will look at: control system upgrades and their obsolescence, 100,000 equivalent operating hour options for the gas turbines themselves, which includes the upgrade or replacement of basic components, the O&M approach for outage management, spare part procurement, heat rate degradation, parasitic load improvements, and minimizing the cost and use of water were some of the technical factors. So the approach summary, again to summarize, we decided that the control system was to be upgraded in phases versus a one-time effort. 2 of the 3 combustion turbines were going to be upgraded to SI3D blade technology. 1 of our GTGs will be upgraded to MAC 41 only. And this approach was a key factor in our decision to shift to a long-term service agreement with Siemens, the OEM. In the past, almost since the beginning of this plant, we handled all of our own maintenance and procurement of spares and all of our outage management. We installed low NOx burners on all machines. Compressor coatings were utilized. Variable frequency drive technology is to be installed on selected equipment. And based on our root cause analysis, selected components within the plant will be replaced or upgraded to minimize the forced outage rate. So that's a summary of the review that we did, looking at both the commercial and the technical issues. So here we just talk about, again, the control system upgrade in phases versus one time. Obviously, the vibration monitoring and protection system is also going to be done in the same phases, utilizing normal gas turbine generator outages. This spreads the budget out over several years and allows for the reuse of scavenged parts to maintain the remaining systems during the interim. The DCS replacement approach follows the same philosophy, and we use Siemens equipment again for seamless integration with scheduled outages, and also all of this is now linked to our long-term service agreement. The logic for upgrading to SI3D and MAC 41, basically, based on our expected operating profile, we knew that we would have face an increasing dispatch with starts and stops. By upgrading to SI3D on 2 machines, we can take advantage of the improved thermal efficiency and heat rate and leave 1 machine so that it can handle more of the starting and stopping duties. So we incorporated some fixed pricing within this hardware upgrade, and we were also able to negotiate all of this at the same time we negotiated our service agreement. So we got a higher level of priority within Siemens to support us. This also makes for easier budgeting and optimizes our outage timing and cycles. Okay, this is what I was just mentioning. That's why we switched to long-term service agreement. Low NOx burners, again, this is a pretty standard thing that's done in many power stations. We needed to reduce NOx to support CLP's emissions and sustainability profile. We get better performance overall actually with these burners. Before we had some flashback issues and some combustion chamber humming, so these were actually better burners for us all the way around. Compressor coatings are another thing that are typical. We decided to proceed with this. We actually had done this earlier on some outages, but now we are going through the complete compressor processes on all of the machines as we do our outages. We decided on a variable frequency drive upgrade, an efficiency project, because it meets CLP's emissions and sustainability philosophy. But also, as I mentioned, the government of India has come out with an initiative where they took baseline parasitic loads and they gave us some challenging targets to meet. So this is a fairly recent project where we're able to, again, minimize the parasitic load and improve our operational performance at lower loads by installing this variable frequency drive on high pressure and low pressure boiler feed pumps. This is just some of the commercial parameters that we looked at because we wanted to see if this project would stand alone from an economic basis as well as to meet the new regulations. So these are some of the considerations and challenges. Obviously, the location selected for the actual drives, it's an existing plant, did not anticipate some of this. So we had to do basic and detailed engineering. Procurement and scheduling of these things had to be done a year in advance to be able to put them in during a steam turbine outage that's coming up. Some of the challenges were from the considerations mentioned above. Again, the integration of the DCS upgrades with these VFDs to support the project. Again, the site location, air conditioning load for these new pieces of equipment, and getting the necessary budgetary approvals to ensure the ordering lead time. Like I said, this was a year to a year and a half before actual installation when we did that. Now, on component replacement to optimize reliability and availability, I just took one example. There are many that we could give, but again, this is quite common in most plants. We had some actuators on our fuel system. These things had frequently failed. In our root cause analysis, it was clear that these were one of the biggest contributing factors to our forced outage rate. In evaluating these things, and again, this is quite common, even in a thermal plant, we noticed that the temperatures that these pieces of equipment were exposed to exceeded their design parameters. And so we were able to go back to the OEM. They had also recognized the problem. They had an upgraded component that we could replace it with. Here's some of the old actuators. Again, it just tells about some of the very specific reasons that they failed. Note the temperatures, etc. Again, you can see the modified version. And basically, this dropped our forced outage rate to actually less than 1%. This thing has really given us a lot of reliability. So in summary, to refurbish, retrofit, or replace, again, each plan is different, and a comprehensive midlife assessment must be done to ensure that all technical and commercial decisions fit together over time. For our plant, the control system replacements were done in phases, utilizing scavenging and refurbished parts in between the phases. We retrofitted SI3D blade technology on 2 machines, upgrading one to MAC 41 only. We retrofitted low NOx burners on all the machines. We refurbished the compressors using modern coatings. Replacement of select prime movers with variable frequency drive. And we selected certain component replacements and upgrades based on root cause analysis. So this is what we did. Again, the important thing, what will be best for you. Thank you.
A list of forced outage, a prioritised list of forced outage root causes. Right. Could you just comment on, if you can recall, what say the top 3 were?
in that prioritised list?
Yeah, it's hard for me to remember, to be quite honest. Obviously, in the past we had our maximal maintenance system, and every time we had an outage or a forced outage, we always do a root cause analysis afterwards. It's actually a formalized process for our continuous improvement program.
Excellent.
So what we've done, and again, I just highlighted one that had a major impact. There were a lot of other areas, but a lot of them were design issues with the combustion turbines. Sometimes it was plant balance and plant equipment that were causing us problems, instrumentation issues, but I cannot list the top three.
No, that's okay. What I was gunning for was the relationship between that list, whatever it was,
Yeah.
and the decisions you made in refurbish, retrofit, replace.
Yeah.
So obviously you did some burner work.
Right.
So
We did again. We had some problems with the forced outage related to humming and some flashback on these machines. And so again, as we looked at opportunities, we tried to sit down and understand what was the problem. Working with Siemens, doing some research, going to user conferences, we decided that by replacing these low NOx burners, we could kill two birds with one stone. So again, that root cause analysis, we went through all the various options that we had and to come up with the solution that worked for us. And again, this goes on every aspect so that we can continuously improve our forced outage rate. And that's what I mentioned. We're actually below 1% right now, which is quite good. So, and that's all part of the root cause analysis process. And again, that's just one.
that's great. Thanks, Ian. Any questions for them? We'll have a microphone.
One thing just I want to know, why you go for coating compressors? What has changed in your parameters that you go for coating compressors?
Okay, obviously you're going to get degradation. This is just normal. What we saw is that coatings around the world were being used, and they can be applied in the field now, which also makes